Okay, let's graph a polynomial function. To do this, what we're going to do is we're going to find the x-intercepts, the y-intercepts, multiplicities, touch or cross, end behavior, maximum number of turning points, and then put it all together in a nice graph. So to get going on this, we're given the function f of x equals x cubed plus x squared minus 12x. The easiest thing to find on here is probably going to be the y-intercept. To get the y-intercept, we're going to plug in 0 for our x value. So 0 cubed plus 0 squared minus 12 times 0 works out to be 0. So we get a y-intercept as 0. The next thing we'd like to do is collect the x-intercepts or zeros or roots, whatever you want to call them. To do this, the easiest way to do it is to have it already in factored form. We have the general form going on right now where it's all expanded. So let's see if we can do some work to do some factoring on this. So the first thing I notice is these all have an x in common. So let's remove that common factor of x. That'll leave us with x squared plus x minus 12 inside our set of parentheses. This will factor a little bit further. Into two binomials, we can say x and x make the x squared. I think we have to go 3 and 4 to make the 12. We're going to make it a positive 4 minus 3 gives us this 1 for our middle coefficient. Now that we factored it, let's bring that down here to pick out our zeros. So x minus 3, x plus 4. If you'll recall, our original function here, f of x, how you pick out your zeros is you kind of go one factor at a time and say, hey, there's an x. What do I need to plug in for this x to make this factor equal 0? Well, in this case, it's just going to be 0 for that first x. The next x, we have x minus 3. We'd have to plug in a positive 3. So 3 minus 3 makes 0. And if that becomes a 0, everything's multiplied together. So 0 times anything else is going to make the whole thing equal 0. For our last x here, we'll use a negative 4. All right, now they're multiplicities. The multiplicities for each one of these come from what power the factor that it came from is raised to. So in this case, each one of these is raised to the first power. So we'd say they each have a multiplicity of 1. Because these are all odd multiplicities, they're all going to cross. Meaning that when you get to that x-intercept, you're going to go to the other side of the x-axis at that point. All right, next up, let's find the end behavior. The end behavior is going to be based on the leading term from our polynomial. So the leading term in this case is going to be x cubed. So if we know what the graph of y equals x cubed looks like, we'll know where the tails are going to end up for ours. All right, so remember, end behavior is based on the leading term. All right, so the question comes up. We have an odd power function. The tails are going to go opposite directions. On the right side, they're going to go up, and the left side, they're going to go down. There isn't a negative attached out in front here, so it hasn't been inverted or flipped upside down. There's no vertical reflection going on. All right, next, we want to find the maximum number of turning points. This can be calculated by the number of whatever the degree is minus 1. It always has to be at least 1 smaller than the degree. All right, we could look back at the original. You're going to notice that x cubed is the highest power on x. In that first term, it's in descending order. That's also going to be the same degree of where we calculated our end behavior. So the maximum number of turning points will be the degree minus 1. We could have a maximum of 2 turning points, meaning maximums and minimums added together, the total number of extrema is going to be 2. Let's see if we can put all this information together and get us a nice graph. So as we're getting going on this, we had a y-intercept at 0. We had x-intercepts at 0, 3, and at negative 4. So I'm just going to kind of put all those points on the graph. The next thing I like to include on my graph is the end behavior. As you notice, we said up to the right, down to the left. So I'm going to just go ahead and sketch that in, that I want to end coming up to the right and down to the left. From here, basically what you want to do is you want to use these directions for touch or cross at each one of our zeros or x-intercepts. In this case, they all cross, so we don't have to be that careful about these directions, but in other examples, you are going to have to be very careful about these directions. So we're going to start at the bottom left with our arrow. We're going to come up, get to our x-intercept. We're going to cross over the x-axis. And as we draw this, we want to draw it so it's smooth and continuous. Smooth meaning no sharp corners, and continuous meaning no gaps or breaks in the middle. All right, and then we come up, come back down. We have to get to this x-intercept. We hit there, we go across. Another x-intercept, we cross there. Sure enough, we finish where we said we were supposed to finish, up here, going up and to the right with our end behavior. Now, a few questions tend to come up on these with students. One is, how do we know how tall this should be? It could be way up tall, or it could stay very close to the x-axis. Same thing with how low does this valley go over on the right-hand side? The truthful answer is, with what we're doing in this class, we're not going to be able to tell exactly how high this maximum is or how low this minimum is going to be at. But that does account for, we have one maximum or turning point there and one minimum or turning point at the bottom. That accounts for our two turning points. You wouldn't want to get wild and go up and down in the middle here or anything like that. So hopefully this helps out as you're trying to graph polynomial functions. I usually think that graphing these isn't that bad. Collecting the information, you just really need to know where to look more than anything else. Y-intercepts is when x is 0. The factored form is going to make finding these zeros or roots or x-intercepts, whatever we're calling them on your problem, a whole lot easier. Multiplicities are the exponents. We're looking at even or odd for the multiplicities to tell us touch or cross. Evens touch, odds cross. End behavior is based on the leading term. So if it's in the expanded version, like we had here, just look for the first term if it's in descending order. Odd power functions, the tails go opposite directions. Even power functions, they go the same direction. Number of turning points is calculated as degree minus 1. Then put it all together on a nice graph, and you've got your polynomial all graphed. Hope this helps. Good luck.